Yes, hi, good evening. How are you all? Hey, I'm also fine. I think you got noticed, right? The JEE mains exam dates. When it will be. Gopi, come here. Hi guys, this is Gopi Chand.
Hello students, I hope everyone is doing good. You might be seeing me once when I was teaching for you, but I don't think so. I have continuously engaged with you. So this is me, Gopishan. I teach chemistry. Okay. So, so guys, I am here to just announce that what is the recent updates. You might have know there is nothing wonder there. Like that is JEE mains dates has been given yesterday when we all are enjoying in Mahashivratri. So it was happened. So basically, registration will be start from yesterday itself. So from March 1st, okay, then it will going to end from March 30th. Okay, so I think don't be late. Okay, just before that, only 2 days before or 1 week before, try to finish it off. And another important thing, what is the date of the examination? So JEE mains is going to occur in two phases. So phase one is going to happen in April, that is 16 to 21st, right? And whereas phase two is going to happen in phase two will be from May 25 to 29, 24th to 29. Okay. So now this year is new model, same as it is paper model will be everything. MCQs. There is a slight confusion. Let me add one screen. So JEE mains basically in two phases. So phase one in April, right? So 16 to 21, and phase two will be May 25 to 24 to 29. And in between these also you are having board exams. Try to concentrate on that too. Not that too. First of all, you need to give best in that. And before this, you are having pre-board. So journey is very long and very important also, very stressful. So try to maintain an agenda. So now the pattern I would like to tell. Okay. So pattern will be, you will have MCQs. There are two sections. Section A, you are having MCQs, 20 MCQs will be provided, plus 4, minus 1 will be there. And section B will be integer type. Okay. Integer type, that is plus 4 minus 1. But here you are having 10 questions. So in 10 questions, you need to do only 5 questions you can do. Choose among 10, best of 5 will be taken care. Many people think that I know 10, I will do 10. No, pick any 5, then do only 5, because this year they introduced negative marks to this integer section. So all the best guys. I hope you got the brief idea about JEE mains. So registration start from March 1st to March 30th. Register in between these time. I hope before 1 week you have to do it. And April 16 to 21 you are having the exam one, and May 24 to 29 second exam. In between you are having board exam. So try to like do your best in the first second attempt. Okay guys, thank you so much. So now your Shankar will continue.
bye. Yes. I hope you guys you all understood this one, right? Okay, do best in all the session. Yes. What is that? Need it will be around in June end or July mid. जुलाई मिड में होता है नहीं ओके नो वरीज let us wait for further 2 minutes Nandish okay let us join one more school has to be joined here we'll wait for them okay later on we'll start our session good and then how you are preparing which exam you are preparing Nandish is it for JE or NEET or both yes that's great okay do well prepare well for the board exam also okay now coming week onwards not only week it means meanwhile if March will be finished means in from next month onwards first onwards you're going to in a fever of completely exam right complete stream of exams will be start board exams and JE and then after NEET and in between that one don't know we KCT exams also might be they're going to conduct okay be ready for those all exam and all the best yes practicals are going on now yeah concentrate more on the CBSE board also okay because if you are not scoring well in a board means everyone will in a village relate means home side means in a village area you are means they are going to identify you as a Navorian student okay if you are not score well in a board also you can't uh, stand that one correct na board ಕಡೆನೂ ಸ್ವಲ್ಪ ಕಾನ್ಸಂಟ್ರೇಟ್ ಮಾಡಿ okay well we will start today's session okay today what are the things which we are going to discuss देखो इधर three things I took here first thing is that spectral series of a hydrogen atom okay next thing is that Bohr atomic postulate and later on we are going to derive the derivation for radius and energy of a hydrogen atom okay these are all three things which we are going to discuss in this class okay before starting the class let's take a quick recall what we discussed in a previous class in a previous class only we started the atom right atom is a fundamental particle or else indivisible particle of a matter correct now actually atom ka bare mein first some theory which is given by the J.J. Thomson correct now later on J.J. Thomson a few ideal concepts which he doesn't explain properly that's why one more scientist came we call that one, that person as an Rutherford correct now according to Rutherford actually he made one experiment क्या होता experiment में actually it took one lead box correct ना lead box actually it is emitting या lead box में क्या होता है bismuth होता है or else radon okay if these two are good agent for emitting the alpha particles emit करने के लिए good particles okay if they start to emit the alpha particle देखो इधर if they okay in front of this one they kept on just a minute guys my screen is not visible properly to me itself okay my screen is visible right the second slide just a minute I will check in YouTube also once yes it's perfect okay in front of that one I placed on good thin gold foil correct now after then yeah in a last to observe he placed one zinc sulfate screen why means zinc sulfate screen is one of the highly photosensitive screen on this zinc sulfate screen he kept on micrometer also to observe the scattering particles correct now if this bismuth will emit the alpha particle means it will emit in all the direction to make collimated direction we kept on lead box here okay that's why the alpha particle emitted one it will be move in this direction and incident on the gold foil. Here we taken a gold foil just because it is highly malleable. Means we can make a sheet. That's why we are taking here gold foil. And you may observe here, right? The alpha particles are scattering in different direction also. And one of the alpha particle will be reflected back while during the scattering. When he observe, most of the alpha particle scattered through the gold foil and observed in a zinc sulfate screen in a directly. Right now, most number of here we will observe. Few of the alpha particles, they are making some angle theta and they are different. And 1 in a 8,000 alpha particle reflected back. From this experimental evidence, he told that yes, here this is a nucleus. Actually, here gold nucleus. Correct now. Alpha particles also coming. Alpha particles is a positive charged particles. Correct now. Here nucleus is also one of the positive element. Here it is reflecting means just because some books it is given 8,000, some books it is given 9,000. Last day I told 8 or 9,000, no problem. Okay. Okay. And then it is reflected means due to some positively charged heavy mass which is present in this nucleus, in this gold nucleus. That's why it is reflected back. This is what the experimental observation he did. And later on, what is happening? Yes, later on he observed the things which are observed. No, we explain a different way. Consider this a gold atom. The alpha particle which is coming near the gold atom. Correct now? This is a first velocity vector. When it is very far away from the nucleus, without deviating, it will be moved straight line. And further, if it is moving very near to the alpha nucleus, okay, instead of going straight line, actually it bent with some angle theta. Correct now? And further, if the alpha particle coming very near to the closer to the nucleus, it will bend more compared to the second one. Correct now? Means here scattering angle क्या हो गया? देखो, scattering angle is increases, right? देखो इधर और एक बार देखो इधर, again scattering angle is increases with respect to the original direction. And if it is alpha particle approaching the nucleus exactly at the middle means it will be reflect back. At this position, the angle will become 180 degree. Correct now? And also this is 180 degree. Here we concluded this one with a graph also. And then below also, if it is moving away means scattering angle decreases continuously. Yes, bro. Yes, I will tell you that one only. No worries. Okay. Here we understood this whole phenomena with a graph. In a x-axis, we took scattering angle. In y-axis, we are going to take the number of particles scattered. In this graph, actually we got like this. Here, it says that in very small angles, 0 to 10 degree or 20 to 90, up to 60, 70 degrees, more number of alpha particles are scattered and they are not deviated that lot and they are not deviated much. Okay. After when they cross 90 degree, it start to reflect. Okay, this is what the observation and experimental evidence given by the Rutherford. And few parameters also they inputted here. What are those parameters? The first one is distance of closest approach. A distance of closest approach क्या है? देखो इधर. This is a nucleus. Correct now? देखो here when this alpha particle actually move towards the nucleus, even it is not touch the nucleus also. Correct now? And it will be returned back. Here, the distance between a nucleus, center of the nucleus to the alpha particle, where it is come rest and it will come again to the original direction. Okay, that distance we called as an distance of closest approach. To to find out the value of R naught, we took here actually here energy में derive किया था हम, correct ना? Here the alpha particle is moving towards the nucleus means kinetic energy decreases, potential energy increases, correct ना? Based on this energy theorem we took, right? According to energy theorem, kinetic energy value क्या होता है? Of mv square, potential energy 1 by 4 pi epsilon naught into 2 times ze square. It is nothing but 2e into ze. Here we took ze for the charge of the nucleus and 2e is the charge of the alpha particle. Correct now? Of here R naught is there, no? This is what the distance of closest approach. Take this one to left hand side, then this equation will become R naught is equal to 1 by 4 pi epsilon naught 2 ze by half mv square. Okay, this is what the equation for the distance of closest approach. Correct. Next one we discussed about the impact parameter. Correct ना? Impact parameter. ये impact parameter क्या होता है? Right? देखो, this is the nucleus. मान लो this is the first trajectory of the alpha particle. First trajectory. I'm taking this as the first trajectory, and this is the angle which is created by the first trajectory. This is what the angle. Right now, if the alpha particle come approaching the nucleus at the exact midpoint, means it will follow this trajectory, no? Midpoint. Now, the perpendicular distance, देखो इधर. Now, this perpendicular distance, B है ना, perpendicular distance to the two velocity vector. This is called the impact parameter. Impact parameter. Actually, देखो, if suppose I'm going to consider the trajectory of alpha particle, this one. This is the first line. If I consider means this will become the impact parameter. Correct now? At this condition, this is the first line. Okay, it is without deviation, it is going. Means there is no angle, scattering angle. If it is approaching near to the nucleus, means it will not go straight line, it will be bent. थोड़ा सा bend होता है. And further, if it is moving towards the nucleus, means again it will bend more. Correct now? Means impact parameter distance. This B value will be increases, means if the B value, sorry, here decrease हो रहा है ना? Sorry. If the B value decreases, means the scattering angle increases. Clear enough? And to find out this B value, impact parameter, we will use the formula this one. Ze square cot theta by 2 divided by 4 pi epsilon naught of mv square. It is nothing but kinetic energy of the particle. This is nothing but kinetic energy. Okay. Right? Okay, good. Next, one more point. I forgot to inform you. And here, when the alpha particle comes to this place and it will be repelled back, means in between these two charged particles here, nucleus Ze, alpha particle 2e. Correct now? In between these two, there is a force will be exist. That force we call electrostatic force. Correct now? That force we call electrostatic force, that is given by 1 by 4 pi epsilon naught 2e q1 q2 by r square. We will write here q1 means alpha particle charge and Ze means it is a charge of the nucleus divided by perpendicular distance r square. Right now, this is what the equation we will use. And one more point, the number of particles scattered. To find out that one, we derive one more equation. N of theta value is proportional to the 1 divided by sine to the power 4 theta by 2. Okay, keep these 2 points. Okay, these 2 are very important as per the NEET examination. Okay, na? Okay, then conclusion. What are the conclusion given by the Rutherford? Actually, here atom contains positively charged nucleus, he told. Yes, good. And the nucleus contains almost all mass, heavy mass which is present in the nucleus. That's why it is reflected back from the nucleus. Alpha particle will be reflected back from the nucleus. And very small volume, okay, but it occupies very small volume. Yes, it is means, guys, if you consider atom is like a cricket stadium. Yesterday I told this is a cricket stadium means nucleus. It is like a cricket ball. Okay, this is what the assumption which we are actually utilizing here. Okay, just imagine that entire mass of this atom is concentrated in a small space. Small. Okay, bro. Okay, okay, Ramesh. Football, ले लो, football ले लो. कोई problem नहीं. Okay, the negatively charged electrons occupy the most of the volume. They are revolving here, and most around in last point, if I want to suggest means around 99.86 percentage of the atom is space is completely empty. Completely empty. These are all the conclusion which is given by the Rutherford. But Rutherford theory also failed. Rutherford theory also failed just because actually he told electrons which are revolving in a orbit. Okay, he didn't say which orbit it is rotating. And also he told that electrons which are revolving in this orbit, this is nucleus, this is a electron which is revolving in orbit means it continuously emitting the radiation. He told that it emits the radiation. Radiation emit कर रहा है means energy कम होता जाता है. Correct ना? If it energy कम हो रहा है means this radius will be decreases continuously, and continuously it is emerging the radiation means finally it comes and fall in the nucleus. If it is fall in the nucleus means then this atom we can't take as an stable. Correct now? It will not a stable atom. That's why we failed to explain the stability of an atom. Stability of an atom. Okay, second one, spectral series को in अच्छे से नहीं explain किया. Spectral series will be formed due to the if radiation is emitting means just a minute. Yes. Okay, if radiation is emitting means radiation in terms of spectral lines will become. Okay, if spectral lines have their own wavelength, right now that wavelength value how it will become, it doesn't explain properly. Correct now, basically based on these two concepts this theory has been failed. Okay, let us understand the spectral series of a hydrogen atom and how Bohr will be come into this to explain the atomic model in this today's class. Before starting the class, I have a small question to all of you. Let me know what is the correct answer for this question. Impact parameter distance decreases, then scattering angle will be. What is the correct answer? Quick. Okay, good. I got one response. Yeah, right. Right, Nagesh. Hey, super. Excellent. Option A is the correct answer. Correct? Now only explain. I think it is not needed to explain once more. Okay, let's get into the hydrogen atom. क्या होता है hydrogen atom? Okay, देखो इधर. मान लो this is a hydrogen atom. Okay, this is a nucleus of the hydrogen atom, right? Allow this is a nucleus. It's completely positively charged. It is completely positively charged. Here some orbits are there to revolve electron to revolve around this nucleus. I'm going to considering this one of the electron. Okay, मान लो ये atom है गैस मॉलिक्यूल का atom. Gas molecule का atom. Now just look at here. If I'm going to supply some amount of heat, क्या supply कर रहा हूँ मैंने? Heat supply कर रहा हूँ उधर. If I'm going to supply the some amount of heat to this electron, what it will do? Actually, it will absorb the heat. Correct na? Heat is nothing but here, guys. It is an energy. Energy will be absorbed by the electron. If energy will be absorbed by the electron, is what it will do? मान लो आपके पास एनर्जी नहीं होता है. You people don't have an energy. If I provide some amount of energy through the chocolates or your tasty foods, what you will do after eating that one? You won't be in your present situation. Means if you're sitting, means you won't sit. If you're getting some energy, means you started to do dance, vagera, 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 right? Correct, na? Yes. In a similar way, if energy will be gained by the electron, means it won't will be in the state in a same state. Same state क्या होता है? देखो इधर guys, इधर orbits है ना, different orbits. I'm going to call this one n is equal to 1 first orbit, n is equal to 2 second orbit, n is equal to 3 third orbit. Okay, n is equal to 4. It's a fourth orbit. Correct now. If it is gaining some amount of energy, means it will jumps to the another energy state. Now it is present here. Another energy state को चले गया. Okay, you might ask here one question, sir. Now the electron will jump from first state to the fourth state. Why it is not a jump to the third state? Why it's not jump to the second state also? Right now, actually, yes, bro. Yes. Actually, it is depending upon the energy with how much you are giving. Energy, how much you are giving. We will actually tell you that one also. In a first energy state, मान लो it is we are going to define this one in the next coming slides. मान लो this is n is equal to 1 means इसका energy होता है 13.6 electron volt. If energy is to second energy state को minus 3.4, third को minus 1.54 energy, fourth को minus 0.74 electron होता है. It is depending upon how much energy you are providing. If you providing the energy, yes, based on the work function. Okay, here how much energy which you are going to provide, based on that one, the electron will jump to the ground state to the higher energy state. Right now, after then, it won't be stopped here like that. Hegel right? Suppose just imagine you are present in your home. Right now, आपका parents आपको पैसा देता है. Okay, they will tell like that, go your relative home and come back. Or else, if you are getting some money, means what you will do? You will go. Imagine like that. Okay, this is your home ground state. You will go into your relative home by absorbing the money which is given by your parents. While coming back, if you have some amount of energy, means what you will do if you have some amount of energy money means ಖರ್ಚು ಮಾಡ್ತೀರಾ ಹೌದಲ್ವಾ? you are going to spend that money in buying some chocolate, some vagera vagera, right? In a similar way, here also, while coming back, yes, you are enjoying, and meanwhile you are not going to stay in that higher energy, means in a relative home only. You are not going to stay for a long time. Okay, if you are coming this last state, means you will be come back to your original state. Correct? Now this is what the process. Similarly, the electron will be coming back to the original state. While coming back, it won't come directly. While coming back, it will emit the radiation. Radiations को emit करता है, right? This radiation contains the energy, that is h nu. Means energy means here completely new frequency, different frequency wavelength को different frequency radiations को emit करता है. Correct? Now by emitting different frequency of light, it will be come to the ground state. Understood what I am saying? Up to this point, is there any doubt? Let me know quickly. Let me know. Train me, Akiri. You people are not responding. Yes, right. Okay, good. Here few things we want to learn. First thing is that, okay, इधर frequency emit हो रहा है, means उसका wavelength कितना है? Wavelength कैसे calculate कर रहा है? Wavelength calculate करने के लिए इन्हें एक equation दे दिया, that is 1 by lambda is equal to r into 1 by n1 square minus 1 by n2 square. I will tell you how this formula also evaluated from this concept. But here Rutherford will not give the clear-cut idea about these all things. That's why it is failed. I'm explaining that one. Okay. Here the value of lambda you're going to calculate by using 1 by lambda is equal to r into 1 by n square minus 1 by n2 square. Here r means it is nothing but Rydberg constant. We call this one as an Rydberg constant. Okay. Next, n1 means it's a ground state. N1 means it's a ground state, and N2 stands for higher energy state. We can call this one as higher energy state. Okay. Lambda means it is nothing but wave length. Okay, now, and one more point I want to input here. Dekho idhar carefully. If electron will jump from where I want to write. Okay, मान लो इधर देखो. If the electron will jump from second orbit to first orbit, electron will jump from second orbit to, this is the second one, this is the first one. Second to first means here energy is less, but wavelength, I will write in a symbol, wavelength is more. Wavelength is more. Clear now? First point. If it is jump from energy state N2, N1 means only one energy state it will be jump, means energy is less, wavelength is more. If in case the electron will jump from higher energy state, here you took n is equal to 4 to n is equal to 1. The electron will be jump from here now 4th level to the first ground state. Okay, this is the first case. This is second case. Now n is equal to 4 to n is equal to 1 means energy is high. High energy will be radiated, but wavelength is low. These things you need to keep in your mind. I hope it is understood, right? Tell me once in a chat box. My PPT is tracking today. I don't know why. And this pointer also blinking. Yes, that's great. Okay, next thing. After this point is over. Okay, two things here you need to remember. First one is which is emitting radiation. Okay, radiation में wavelength होता है, frequency होता है. Wavelength calculate करने के लिए we are using the formula 1 by lambda is equal to r into 1 by n1 square minus 1 by n2 square. Here n1 will always stands for the ground state, n2 will stands for the higher energy state. R stands for the Rydberg constant. Okay, here based on the jumping of the electron, if it is jump from very less amount of energy state, means energy state 2 to 1 means it emits the less amount of energy, but it emits more amount of wavelength. Wavelength ज़्यादा होगा. If it is jumps from both ज़्यादा states से means higher energy states to ground level state means it will emit the energy is high but wavelength is lesser. Okay, we'll understand this one through the spectral series. Okay, few spectral series are there, might you know, right? Lyman series, Balmer series, bracket series, P-Fund, Passion. Right now, one by one, we are going to study. Okay, just a minute. Okay, we are studying these all the series of spectral lines with the help of hydrogen atom. Which atom? Hydrogen. Carefully you listen, guys. Hydrogen atom. Hydrogen atom means here the value of Z will be equal to 1. Right now, just a minute. Z value will become 1. Clear enough? Now, one low. These are all the energy levels. Okay, I will name this one as an N is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, like that. Infinite amount of energy levels I am going to take. Okay, now guys, देखो इधर. So now carefully, if electron will jump from second energy state to the first energy state. Second to the first energy state it will jump. Especially in Lyman series, I'm explaining guys. In chemistry, you already studied this one. In Lyman series, क्या होता है? Electron will jump from higher energy state to ground state. Always it will jumps to the energy value will be equal to 1. N value equal to 1. Ground state 1 को equal होता है ना, उधर jump करता है electrons. Means second state to the again first state. From third state also it will jumps to first state. From fourth state to again first state. From infinity also it will jump to first state. I hope you guys understood. Electron here means spectral series of hydrogen atom for the Lyman series, especially for which series? Lyman series. Electron will jump from higher energy state to ground state, that is equal to 1. Okay, now I already told you guys, that here the if energy means electron will jump from second energy state to the first energy state, means what will be its energy comparatively if the electron will be jump from infinity to the first ground state energy. Ground state, if so no, first scenario is that electron is jump from second state to the first state. Second scenario is that electron will jump from infinity to the ground state. In these two case, which in these two case, energy is highest for sorry, yeah. High energy is highest for in which among these two? Let me know. Extremely sorry. Yes, because electron will jump from infinity to lower energy state, means it has a highest energy. Higher energy. But if the electron will jump from second to the ground state, means it has a low energy. Okay, now we'll calculate this one through the formula. Then we will get an idea about it. Okay, इसको calculate करने के लिए wavelength calculate करना है पहले. Okay, wavelength का meaning आपको पता है ना, 1 by lambda is equal to r into 1 by n1 square minus 1 by n2 square. Correct now? Either r value I will write. This r value is nothing but 1.067 into 10 to the power of 7 per meter. Per meter. This is the value of r. We call this one as an Rydberg constant. I already told you. Okay. Suppose मान लो first case को calculate कर रहा हूँ मैं. 1 by lambda is equal to r value कितना है 1.067 into 10 to the power of 7 into 1 by n1 square means 1 by 1 square and minus a n2 square है ना, it will be coming from infinity. Correct? Just a minute. Sorry, n2 means here. Just a minute. n1. क्यों ऐसा किया मैंने? Sorry. First state, okay, which state it is coming? N2 square means from which state it is coming actually. Correct now? N2 means here from 2. First one, I'm calculating this one. Okay, here 1 by 1 square is nothing but 1 minus 1 by 2 square. It will become 1 by 4. Correct now? And 1 by lambda will be equal to 1.067 into 10 to the power of 7. If you are going to calculate this value, means guys, here 4 minus 1 3 by 4 होता है. Either just calculate this one, you will get around 1000. I calculated this one, that's why I'm writing here 1250 angstrom you will get. 1215 angstrom. This is for the electron which is jumping from second orbit to the first orbit. If the electron will jumps from second orbit to the first orbit, means it emits the radiation in the wavelength region will be 1215 angstrom. Clear now? Similar way, second case. In second case, same, but N1 you need to take one only, ground state it will become, but N2 it is equal to infinity. Infinity से आ रहा है, correct ना? In this case, you will get lambda value around 911.3 angstrom. I calculate this one, that's why I'm writing directly. Okay, if the electron which is coming from infinity, electron which is coming from infinity to the ground state means which emits the wavelength around 911.3 angstrom. राइट, ये देखो इधर, ये दोनों केस में दिस इज लैम्डा फ्रॉम इंफिनिटी व्हिच इज एमिटिंग, दिस इज लैम्डा फ्रॉम सेकंड स्टेट, करेक्ट ना? हमको एक इक्वेशन पता है, एनर्जी इज इक्वल टू एच न्यू, करेक्ट ना? हियर एच न्यू मींस सी बाय लैम्डा, मींस एनर्जी के साथ लैम्डा कैसे रिलेट होता है? इनवर्सली प्रोपोर्शनल. If lambda value is increasing means energy value decreases, correct ना? देखो इधर comparatively these two, 1 and 2, right? 1 it has a highest lambda, means wavelength तो बहुत ज्यादा है comparatively second one, means in this case ये फर्स्ट केस में एनर्जी क्या होता है? डिक्रीज होता है, इधर एनर्जी increase होता है, correct ना? It means that if the electron will jump from higher energy state to ground state means इसका energy ज्यादा होता है but wavelength कम होता है, correct ना? If the electron will jump from small energy state means nearby the energy state means उसके wavelength तो बहुत ज्यादा होता है but energy तो बहुत कम होता है. Clear ना this point? बहुत ज्यादा बोल दिया मैंने, थोड़ा मिस्टेक भी हो गया था, ठीक कर दिया मैंने, करेक्ट ना? इज इट अंडरस्टूड गाइस? यादगिरी, मंदीश, cool. This is all about Lyman series. In Lyman series, electron will jump wherever the electron will be there. There no mind. Okay, it will jumps to the ground state itself. Means n is equal to 1. इधर आता है, clear ना? Okay. Next thing, Balmer series. In Balmer series क्या होता है? This is also spectral series only. Okay. In Balmer series actually these are the energy levels. I will call n is equal to 1, 2, 3, 4, 5, 6, 7 up to infinity. In Balmer series actually electrons which are present in our excited state means higher energy state which are actually jumping to the ground state, but इधर बाल्मर सीरीज के लिए ग्राउंड स्टेट का वैल्यू होता है 2. कौन सा? 2. मींस here electron will be jump from second energy state to the first energy state, means here second energy state होता है 3, first energy state होता है 2. Similarly, if the electron present in a fourth energy state means it will jumps to the second energy state, and fifth to the second energy state, sixth to second energy state. Like from infinity also it will jumps to the second energy state. Clear na? Clear, right? Okay. Now देखो इधर again same condition, nothing is changing. Okay, if electron will jump only one orbit level means energy less, wavelength more, correct na? Here if it is transition takes place from infinity to the ground energy state 2 means here energy will be more, wavelength is less, correct now? In this case guys, you need to take two composition again, same way. Lambda value will be means 1 by lambda is equal to r into 1 by n1 square minus 1 by n2 square. Guys, I'm informing you all this equation also we are going to derive in a coming slides. Okay, coming class also. right? If you substitute here, n1 value is equal to 2 because it is a ground state for the Balmer series, and n2 is equal to from infinity. Correct now, or else for the first case, this is the first case means you take here n2 as an 3, and if you calculate the value of lambda means you will get around 6530 angstrom. This is for the first case. First case to either hai. This is the first case. First case means this one. Okay, it emits the wavelength. Here it emits the wavelength 6530 angstrom. But similarly way, next second case, this is the second case. Second case को calculate करने से 1 by lambda value. Here you need to take n1 value is equal to 2, but n2 value you need to take infinity for the same equation. Okay, at this situation you will get the lambda value around 3563 angstrom. Means here second case में infinity to ground state n2 आता ना, either it will give the 3653 angstrom. This is the wavelength. Okay guys, do observe here 6530 3500 see 3653. In which region it will become? Yes bro, the value of R is constant. It's a Rydberg constant, we will say. Rydberg constant. Guys, tell me that, do you know these values? 6500, 6530 angstrom to the 3653 angstrom. What it actually says. Actually, guys, these two are visible wavelength region. देखो, correct ना? Visible wavelength region. करना दिखता है हमको. From violet to red, विब गया. Correct ना? In this order it is there. Means here in Balmer series, actually it gives the visible wavelength of the radiation. The radiation which is emitting here, no, that is visible range. Clear? Balmer series clear hai na? And you might ask the question, in Lyman series where it is available. So what it is available? In Lyman series देखो, in Lyman series में 911 to the 1215 था ना, it will become under ultraviolet region. It will become under ultraviolet region. Note on this one. This is very important. Clear? Okay, coming to the next point. Quickly we will move. Okay, next one is I will explain all these three in a single slide. Okay, first thing we'll go through the Paschen. Paschen means we need to first give the value of n. N value will be n is equal to 1, 2, 3, 4, 5, 6, 7 up to infinity. Correct now? Here Paschen series mein electron will comes to the state of 3. 3 is the ground state for the electron. Okay. First point will be come from electron will be jump from n is equal to 4 to the 3. Next one 5 to 3. Next one 6 to 3, 7 to 3, and from infinity to 3. Correct now? Here just you need to know that first n1 value will be 3 होता है, and then n2 value क्या होता है 4, 5, 6 etc. up to infinity. Clear ना? This is for Paschen. Which one? Paschen series. Okay. Next thing. Next one bracket है. Bracket series के लिए ground state होता है 4. Okay. Then electron should be jump from 4th state to the third state, fifth to third, sixth to third, and from infinity to third state. Okay, this is all about the bracket, right? And then last one, but not the least, yes. Yes, right. Okay, last one, P fund. Okay, P fund series may actually ground state hota hai fifth one. Okay, means electron should be jump from P fund. Found nahi, it's a P fund. Okay, electron will jump from sixth to fifth state, and then seventh to fifth, and like that from infinity to fifth state. This is called P fund. Actually, I don't know deeply about this one. Right? It's a completely chemistry, no? So adjust karo. P fund. Here, same thing, same thing. If electron will be jump from lower energy state to lower energy, means it emits the less amount of energy, but it emits more amount of wavelength. And the wavelength region from passion, bracket, P fund, all these are come under the region of infrared rays, IR rays. Okay, in IR rays it will become, right? This is all about the spectral series. If it is understood, means we'll quickly move to the next slide. We'll move. We'll move. Late or correct now? Yes, that's great. That's great. Yes, actually, these are the spectral series. What we discussed now, it is not clearly explained by the Rutherford. Now, the new scientist came across this field. We call his name as an Niels Bohr. Okay, he given some postulates of the hydrogen atom, how the atom is there, how the atom is there, and how it will be emits the radiation and everything. Okay, let us take one by one postulates. Okay, this is a nucleus, right? Nucleus, entire positive charge will be present here, and nucleus को represent करते हैं Z से. Z is the charge number, E is the charge. Correct now? If any electron will be revolving around the nucleus, means it has one fixed orbit. He will tell first one is that it has a fixed orbit. Fixed orbit means from the nucleus it has one fixed distance, no, like this. It is not visible. Let me write through another color. Okay, it has one fixed distance. This fixed distance is called radius. He called radius. And also he told one more point, if it is energy, okay, electron, if you're going to give some amount of energy, means it will jump from, this is the energy level 1 you call, okay, you call this one as an energy number 2, A2. If it is jumping from energy 1 to 2 means, right, it emits the radiation, or it will jump from energy level 2 to the energy level 1 means it will emit the radiation. Correct? That is also he explained. And he told one more point also, each energy state having their, means each orbit has its own fixed energy. Fixed energy hota hai. Meanwhile guys, question hai yenilla from n is equal to 1 in the n is equal to 2 ಹೋಗಬೇಕು ಅಂದ್ರೆ ಇದಕ್ಕೆ some amount of energy ಬೇಕು. Fixed amount of energy ಇರುತ್ತೆ. If in case n ಇಂದ 3 ಹೋಗಬೇಕು ಅಂದ್ರೆ ಇದಕ್ಕೊಂದು fixed amount of energy ಇರುತ್ತೆ, ಅಷ್ಟು ಕೊಟ್ಟರೆ ಮಾತ್ರ ಅದು ಹೋಗುತ್ತೆ ಅಲ್ಲಿವರೆಗೆ, ಇಲ್ಲ ಅಂದ್ರೆ ಇಲ್ಲ. Like that, if it is want to go from n is equal to 1 to n is equal to 3 means it has certain amount of energy, fixed amount of energy. That is actually he said in a first postulate, in an orbit or atom, it has one fixed radius. Fixed radius means electron are revolving in around the nucleus. In an orbit means it has one fixed distance. That distance is called radius, and each orbit has fixed energy. Each orbit has its fixed energy. Clear now? And one more point you need to keep in your mind. If an electron, this is an electron, okay, if you give amount of energy means it will, I told that if it will be jumps to the higher energy state, but it won't jump higher energy state from ground state n is equal to 1 to n is equal to 3 directly. It won't jump like that. It will reach first n2 and then n3 and then n4. Like, just imagine this is a ladder. This is ladder. ओके किधर है लैडर? मान लो एक कंपाउंड के ऊपर है. ओके, compound, this is me. If I want to climb this ladder, means, okay, in each and every step I want to put my leg. In each and every step I want to put my leg. In a similar way, electron will jump from ground state to the next state. Means high energy state को जाने के लिए it has to cover each and every states. N is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4, n is equal to 5. Like that it has to go. It will not go from directly from 1 to infinity or high energy state. It covers each and every orbitals. Clear na? This is the first postulate. Second postulate क्या है? Second postulate क्या है? बोलता हूँ, देखो इधर. This is actually I told you nucleus. चार्ज तो Z ही है. Hydrogen atom means the value of Z will be equal to 1. Correct ना? मान लो this is the electron which is moving in a circular path. The electron which is moving in a circular path means it has a velocity. Or else, just guys, it is me. Okay, if I'm walking in a road means, मेरे साथ मास तो होता है. Walking in a road means मेरे साथ velocity भी होता है. May I know what is the product of mass and velocity? Guys, what is the product of mass into velocity? What we are going to call this one? Mass into velocity. That's great. Momentum होता है. Hey, momentum. Similar way, electron which is moving in a circular path means इसका पास भी एक momentum होता है. That momentum is not a linear momentum. Linear momentum is straight line में pass होना वाला. Here it is moving in a circular orbit. Correct ना? That's why it has a angular momentum. Correct now? Actually, we are going to represent this one with a letter L. Angular momentum का value क्या होता है? L is equal to mvr. This is the value of angular momentum. Simple है यार. Momentum P is equal to mv. No, this is the linear one. If you want to turn on this one to the angular momentum, L means just multiply the value of radius. It is the value of angular momentum. That's it for every quantity. Right? You know, right? S is equal to, it's a linear displacement. In angular displacement, you want to write means theta, just multiply r. Linear velocity v, angular velocity omega. If you want to convert this to means relation means multiply with r. Right now, linear acceleration a is equal to angular acceleration alpha multiply with r. These are all the things which gives the relation between linear quantity and as well as the angular quantity. Coming to the point later on. मुझे और एक class है. Okay, it is moving with, suppose मान लो n is equal to 1 state में it is moving means it has some angular momentum. He given that second postulate as an the electron which is giving in a certain orbit, its angular momentum value L value is equal to nh divided by 2 pi. ये equation को equal होता है. Like that he told. Here h stands for Planck's constant. Okay, and this n stands for the principal quantum number. Principal quantum number. A principal quantum number क्या है? That is nothing but n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4. These are all the principal quantum numbers. Okay, what is the second postulate means? Electron which is revolving in the orbit means it has an angular momentum. That angular momentum value will be equal to nh upon 2 pi. Correct now? मान लो this is the first orbit. Guys, this is the first orbit. N is equal to 1. Then angular momentum value कितना होता है? L is equal to n value you have to put equal to 1 h divided by 2 pi. This is for first one. मान लो this is second one, right? Means n value will be 2. Then angular momentum value क्या होता है? 2h upon 2 pi. Correct? Like that, angular momentum value will be vary होता है जिसके साथ principal quantum number के साथ. This is the second postulate. Guys, whatever the postulate which is given by the Bohr, no, we are going to prove each and everything. We will prove this one. Keep in your mind. Okay. This is the second postulate. Third postulate को jump करता है. Now, third postulate ये ही है. क्या है ना? This is again hydrogen atom that is equal to 1. क्या कर दिया मैंने? Okay. Nucleus. This is the first energy state. This is second state. N is equal to 3. What he told? No. First postulate में he explain किया था. Each energy state having their own energy. E is equal to 1 for this one, energy 2 for this one, energy 3. If electron will be jumped from second energy state to first energy state means it emits the radiation. Correct now? That value will become E is equal to h nu. How much amount of energy it will be radiate? That is we are going to calculate here. Actually, energy means here two energy levels. It's a change in energy level. That is E2 minus E1 is equal to h nu. Correct now? Actually, already told you one point. This first energy level has an energy around minus 13.6 electron volt. Correct now? And this second state having an energy minus 3.4 electron. Now we'll check how much amount of energy required to move this electron from ground state to higher energy state. Correct now? Actually concept है emission of electron, sorry, emission of radiation means here emission of radiation means we have to send this electron from ground state to higher energy state. No, how much amount of energy required for that? Actually, this is what explained by the third postulate. Look at here. Energy of the 2 means it is nothing but minus 3.4 electron volt minus first energy state E1 means minus 13.6 electron volt is equal to h nu. Correct now? Here minus into minus it will become plus. Correct now? 13.6 minus 3.4 means it will become around 10.2 electron volt. H nu is there. H nu is nothing but E. Means energy कितना supply करना है आपको to jump an electron from the energy level 1 to energy level 2 means you need to supply this much amount of energy. Means 10.2 electron volt amount of energy you need to supply. Then only the electron will be jump from first energy state to second energy state. This is actually the postulate which is given by the Bohr as a third one. Right? Yes. Thank you. And this is all about today's class, guys. And we'll meet in a tomorrow class and we'll say and we're going to define each and everything of the Bohr's atomic model. What are the things means? What is the radius? What is the energy? If it is moving in an orbital means what will be its velocity? What will be its wave number? What will be its wavelength which is emitting? Correct now? These are all the things which we are going to discuss in our tomorrow class. Okay. I hope you all enjoyed this class, right? Let me know through the chat box quickly. Oh my God. Thank you. Thank you. Thank you. And take care. We'll see you in our tomorrow class. Bye-bye.